So this is our final chapter 6, and in the last week we are just try to predict the model shape induced by the Bedload transport and the turbulent flow. So after we understand what the major dominant power spectrum density amplitude caused by the Bedload flux, and then we can move to the next step. The next step, we are trying to estimate the Bedload flux just based on the input data is the seismic signals. Okay, so as I mentioned, totally we only consider 2 models, and the first model is the Bedload models, and the second model is the turbulent flow model. So I didn't go into details for the model predictions. So I just try to teach you how can we done for the model predictions. And then this is just a slide. I summarize all the input parameters for our programs. And the most important thing here is for your side, you should understand the river geometry parameters, like the river bed slope and the river channels width, and some diameters distributions for the grain size. And then you should understand know the sediment densities. Okay, and then after we determine all the parameter for the input, all the input parameter for the prediction models, and then for our exercise, we just pick up one specific time related to the August 24 and the 2-hour UTC plus 0 time. So the local time should be the August 24 and 10 o'clock in Taiwan. So and for after I pick this time, and I know at this time the water depth is equal to 6.18 meter. And then so based on the input water depth, and until now I only have the one parameter is the unknown parameters. So it is our interesting parameters for the Bedload flux. So as I highlight here, all of the parameter we already know. So we only have one parameter we didn't know after before our analysis. So our purpose is to try to determine the final Bedload flux. Okay. So this exercise in last week, I used the initial value is 0.01 for the Bedload flux. And I do the model predictions. After I do the model prediction, I apply the program. The name is the PSD PRED prediction programs. And all the parameters summarized in the PARA dot input. And the interesting frequency I use is the start from the 0 to 100 Hertz. After I do the model prediction and on your screen print, you can see this is the final, the Bedload flux we have. So this is, even though I initially used the 0.01, but the final is 0.00323 at all. And then you can see some peak frequency at the certain values, okay? And then after we run the code and we apply the script to plot the result, and based on the result, you see the red line in here is our observed data. And you have the black line here. The black line here is all the prediction PSD values combined 2 models. And for the individual models, the Bedload is green line here. And the turbulent flow model is the blue line here. So you can make some conclusions. The energies with the frequency higher than 10 is caused by the Bedload transport. And the lower than 10 Hertz is caused by the turbulent flow. It's just because the blue line in here is higher than green line. And after the 10 Hertz, the green line is higher than blue line. So that's why you can make some conclusions, the dominant frequency for different models. Okay, and then I can summarize the result because for the model prediction, this is my input, but the output result in here, and we can see the image is here. So our purpose is, can we adjust the different input Bedload flux until the black line are quite close to the red line here? Because right now the black line is not perfect fitting the red line here. So I wondering to adjust the different input QB values here and to see what happened on the map. And the time I will stop because when the red black line curve here are quite close to the red line here, and then I will stop my analyze. Okay, so I just summarized the today's framework because I almost fix all the input parameter as I table showing here, and then I try to adjust the input QB values. Where is my input QB values is here. I just try to different input value here. So how many try values we will use today? So I list in here 0.05 and 0.1, 0.3, 0.5, 0.8, and 1. So totally we have the six value, and we will try, and we will see what happened on the map. Okay, and because I have only teach the two model predictions, so based on the turbulent flow and the Bedload model, and we will after we done the 6 times, and we will different result from the different try, and finally we will determine which one is the best one, and the best one is our final QB values. Okay, so that's only the framework today. We will do some exercise. Okay, so right now is the first try. We wondering to try the different value here. Initially this is 0.01, and we wondering to move the 0.01 to be the 0.05. So right now we should open the terminal. Okay. So, and we go into the work, the course, and the 111 time frequency, and the personal folders. Okay, and in here I make some folders. Maybe I repeat to make the folder. So right now I'm located in the my personal folder. And I wondering to make the today exercise folders is chapter 6, and this is the maybe the Bedload and the estimations. I just choose the folder names I want and try to make the dir. The make dir is to create the folders. Okay, and after I create the folder and you type the ls, you can see there is the folder I created right now. And I'm trying to copy the chapter 5. Inside the chapter 5, we have the program. The name is the PSD and the underline prediction. This is the main program we need for the model predictions. Okay. So I can copy this file into the chapter 6. Okay, so I just try to copy the major programs and into the chapter 6 today. Okay, so copy and enter. Okay, and another files I also want to copy to the chapter 6. So copy CP and the chapter 5, and the file inside is input the parameter we need. So I wondering copy the input parameter in the chapter 5 folder. The name is tara.inp into the chapter 6 Bedload estimation folder. Okay, so after I copy 2 files, and then I can do the model prediction, right? So right now I can go into the chapter 6 I create right now and go inside and LS to check all the file inside the chapter 6. So before we do the model prediction, you should make sure the 2 files are already in your chapter 6. The one is the main program files, the PSD underline prediction, and another is the input file. The tara.inp is our input file. Okay, and then before we run the code, we should know the input parameter. And how can we done is we wondering to change the input Bedload values here. So the last week we tried to use the 0.01 value to do the model predictions. But right now, based on the PPT slide, I have some suggestions. Totally, we have the 6 times try the QB values. The first one is 0.05. Okay, so I only change the input values here, and then I fix all the parameters for the others, and then save the file, and say yes, and enter, go outside. Okay, and then if you forgot how to run the code, so I use the main program name is the PSD underline predictions, and I need to provide the parameter file here. Okay, and the interesting frequency band I want is the F1 is the lower frequency is 0.0, and the upper frequency F2 is equal to 100. Okay, so all the comments are the same as compared to our last week result. So I just after I run tap the enters. Okay, good. And as you can see, it's just some files we don't have in the current directory, right? So we should also copy some tst file inside here. So we go outside, and we copy some files required for the main programs. So again, we copy the chapter 5, and inside we need the PG font tst. So we need the PG font tst file. And I copy the file into the chapter 6. Okay? And enters. And another file is required for the main program is the rgbt.tst. Okay. And also copy to the chapter 6. So initially, I just copy the main program and input the parameters, but I forgot to copy 2 files are necessary for the main program is the PG font TST and RGB TST. The 2 files, one is control the character on the map, another is control the color on the map. Okay, so after I copy the 2 files and I go back to the chapter 6, the Bedload estimations, and I re-execute the code. So I re-execute the code. So right now I use the main program parameter input files and the frequency band that I want. And then I can tap the enter. And if you see the same result on your screen, so we finished the one try. So we only adjust the different input QB values and change the QB value to be the 0.05. After that, I run the code. And you can see the difference value here. Compare the result in last week. Okay, so I already copied all the result on the slide. So you can double check the result is the same or not. So this is the number I highlight here with the red colors. It is the number right now as same as we do the analyze result. Okay, so the next step we try to make the plot. Because we already run the result, so we should make the plot. So all the plot script we already done in the last week. So right now we wondering to make the plot like this patterns, and you can see the black line are going up a little bit. Okay, so we are trying to make the plot. So open the terminal. And then we can copy, maybe we can go back, we can go outside. And how can we do? We can copy the chapter 5. And in the last week, we created the one file for the plot, is the chapter 5.sh. So we will have the chapter 5.sh, right? And then we wondering to copy the chapter 5.sh into the chapter 6. And during I copy the data, I wondering also rename the files. So right now I already assigned the copy this file into the chapter 6, right? But I wondering to edit the different file name. So I use the chapter ch6.sh. That indicates I want to copy the name to the chapter 6, but rename the file to be the chapter 6.sh. Okay? So after I do that, and I go back to the chapter 6, and you will see the files right now located here. The chapter 6.sh. Because I copy the chapter 5, but I copy to the chapter 6 folders, but with a different name. So the name will replace. Initially, the chapter 5.sh will replace by the chapter 6.sh. Okay, so if in last week everything well done in your chapter 5.sh file, and you can plot the result on the last week. So right now we can directly to run the code. No, wait. Because the nano you chapter 6 sh, you can nano the chapter 6.sh, and you see all the all the file names are not the chapter 6, right? Because you see right now the file is chapter 5.ps. But today our exercise is chapter 6. So we're wondering to modify all the chapter 5 to be the chapter 6. So as you remember, we have the command here. We can use the replace command. Okay, so control and have the pipeline. And you can put to search where you want to replace. So right now the character is a chapter 5. I wondering to replace by the chapter 6. So the search the chapter 5, and then I wondering to replace by the chapter 6. So you tap the enter, and then you can tap what you want to replace. So I wondering to replace the chapter 6. and enter, and replace all. So I tap the A, and all the chapter 5 characters in the file will replaced by the chapter 6 after you execute the replace command. Okay, so right now we can save the file and say the yes and enter, and then we can run the code, the chapter 6.sh. So the super quick, just finish it to plot the result. And then you can open the FTP. My FTP location here, and go into my personal folders, and the chapter 6. Okay, so this is the result I have done. And then you can see in the figures, we cannot see any red curve. As I mentioned, the red curve is the observed data. So that means in this folder, there is no observed data file. So we should also copy the observed PSD data into this folder. So right now we can go back to the terminals, and what are the file we need to copy. So you can go back in here, and we should have the input file for the observed data inside the chapter 5. So as you remember, we can go into the chapter 5 to double check what is our input data for the PSD. This is 2 hours. .txt is our observed data. So we should copy this file into the chapter 6. So we copy. Right now I'm located in the chapter 5. So I can directly copy the 2 hours .txt. I want to copy this file into the chapter 6. So where is the chapter 6? I need to go outside, and chapter 6 will be found. Okay, I go outside and put the data into the chapter 6. Okay, and enter. Okay, and I go back to the chapter 6 folder. Okay, so right now I'm located at the chapter 6, and double check. In the chapter 6, you can see the 2 hours.txt file. The file includes the observed PSD values. Okay, so right now I can replot the chapter 6.sh. Okay, so tap the enter and recheck the figures. So we update the figures. Okay, sorry. So you can see for this time, we can plot the red line, because for the first time, we don't have the file. So you cannot see the red line. So right now we copy the 2 hours TXT file into the chapter 6. After we do that, so and replot the result again. And you can see the red line is our input PSD data. Okay, so we already finished the first try. So you can go back to see the result compared to the slide. I put the result here are the same. So what is our next? The next, we can also change the 0.05 to be a 0.1 and do all the analysis again. But after we analyze the different try, and our figure will replace by the next run. So right now I want to move. This is the PNG file. Where is my PNG file? Here. This is the PNG file for the try the input QB is the 0.05. So if I run a different try, the file will replaced by the new result. So I wondering to rename the bigger file names. So move the chapter 6 PNG file to be the chapter 6, and underline maybe the QB is underline 0.05 dot PNG. And after I move I rename the result, and I can save the figures. And because I totally finished all the try, and I wondering to compare the total result. So I will open all the figures and compare what difference they are. Okay, so I wondering to save the file for the output figures. So after I move the, you can see the file name changes for a PNG. And then we can edit the input parameter again. So right now I added the input parameter again. Nano the PARA dot input. And the last try I tried use the 0.05 QB values. But right now I wondering to try the difference is to be the 0.1. Okay, and then fix other parameters don't change. We just one time we only change the QB value. So save the file and run the code. So our main program again is the PSD underline predictions, and we require some input parameters. Okay, and the frequency is f1 equal to 0.0, f2 is equal to the 100.0 hertz. Okay, and run the code. And then you will see in this time the result, the value also different. Okay, so for every time you run the code, you should write down the value here, because it is very important for our final analysis. So for each time, you should copy paste the result. Okay, even though I already copied on the slide, so you can double check the value is same or not. So we can open the slide. You can see, based on my slide, the result, the number are the same. Okay, totally the same compared to your green screen. Okay, so after I run the major programs, and then I will make the plot again. So I go back to the terminal, and how can we plot? We just run the chapter 6.sh. Okay, and enter, and super quick, and already finished converted to the PNG file. So right now I can open the FTP and recheck the new result. So this is my new result. This figure is my new result. So I also want to save the file for this result. So right now I move the chapter 6 PNG file into the chapter 6 and underline the QB is equal to 0.1 and the .png file. And I can ls again. So you can see ls, and you have the QB, the first try is 0.01, the second try is 0.1. So in the following, we have the 6 try we need to finish. So finally, after analysis, we will have the 6 PNG file in here. So it's okay? 有人跑不出来的吗？那我就不客气咯。So right now we still have the 4 try we need to finish. So for your side, you can go ahead. Don't wait for me. Okay, so how many try we need to finish? So we go back to the slide, the framework. Here, we already already done the 0.05 and the 0.1, and then we still have the 4 tries. So the 0.3, 0.5, 0.8, and 1. So after we finish, we can have some discussion. So for your side, you can go ahead, just run your code. And if you finish, you can break. And after the 10 minutes break, and we can go back to discussions. So right now you can do yourself and just try to finish all, and you can break free, okay? So for me, I nano and parameter input and change the 0.1 to the 0.3, okay? Okay, and save the file and run the code. And after you run the code, you should take care for the final QB values. Okay, and then I replot the result. And I move the chapter 6 PNG file into the chapter 6. Rename the file to be the QB, and then right now the QB is 0.3, and then the PNG file. Okay, and then nano again, and change the 0.3 to the 0.5. Okay. And save the file and run the program. And then you can see also the final Bedload plots are different values in this case. And replot the result. And then move the chapter 6 PNG file to the chapter 6. The QB right now is 0.5 PNG. Okay, nano the 0.5 to be the 0.8. And save the file and run the code. And make the plot SH. And move the chapter 6 PNG file into the chapter 6. The QB right now is 0.8.png. Okay, and nano the parameter. The final try is 1.0. So for your side, if you try the different values, and then for each try, you should keep in mind, before you plot the result, you should save, copy and paste the result for this time. Because the different try, the number in here will have a different result. So the final QB result we want is here. So you should save every time after you run the code. And after I save the numbers for the final QB values, and I will run the plot script and move the chapter 6 PNG into the chapter 6 QB, and right now the QB try is 0.1.png. Okay, after I finish all the try, and I have the PNG 0.05, PNG 0.1, 0.3, 0.8, 5, and 8, and 1. Okay, so totally we have the 6 time try. And you can try much more. Not only the 5 and the 6 try as I suggestions. So for your side, if you wondering to know if I try much higher values and what are the pattern changes in the model prediction result. OK， 那大致上就是我们做完就休息，那我们等一下就回来。那就自己把这6次把它跑完。 那这6次是我随便设的6个，其实实际上你要再试更多的答案或试更多的尝试，其实在你那边随时都可以做。那大家也可以看到我刚刚在做的话，我做一个不花1分钟，所以我1小时最起码也可以做个60次。哦，那当然正常来讲，我们不会用手动的方式这样一直做，但是因为这堂课我们不是要教大家写程式，所以我们主要就是让大家这样子尝试错误，这样一次一次一次一次。那你自己每一次的时候，千万一定要记得把这个答案存下来。哦，这里有这个答案。以后如果你自己跑的话，那这个答案一定要存下来，因为这个数字才是我们真正的 QB 值，我们真的用的 QB 值。那你所输入的那个是他尝试用这个值去算，可是它不会是真的是那个答案。OK， 所以我们要的其实是最后的这个 QB 值，不是我们一开始尝试的那个值。OK， 哦，所以这个很重要。你不要看我这样按好像都没有存，那是因为我已经把它存在简报档里面了。我的简报档每一页都要把这个数字存下来，每一页都要把这个数字存下来，好不好？那你就是做完以后，我们休息，我们大概2点20或是20几分的时候再回来。OK。